Where does it get the information? Oh, in this case, this is something, maybe I didn't make that clear, I'm sorry. This right here, this part right here, this is typed in by the user on the keyboard. So the scanner lets you get keyboard input from the user. So this isn't something that I was printing out, this is something that the user typed in. Does that answer your question? So the question was, where did the user type it in? In line 12, and I don't have like the physical computer open right now, or I can show you, but maybe I will afterwards. In line 12, this scanner.next line, that says, hey, go to the keyboard and get some input. Because the scanner is linked to the system's input. Does that make sense? Okay. And then I think, yes.
Why would the dot, even though it's after the new line, still comes up on that?
Because I had an error. Because the dot should be before that. I made a mistake. So the question was, hey, how come the dot doesn't show up on the next line? And actually, it would. I just, when I was typing up this slide, I made a mistake. This slash n should have been after the period. So my apologies. Does that make sense?
Yeah, I just wondered.
Yeah. Yes, sir.
After you make the new scanner, why does it say string response?
String response says, basically we're saying, hey, I need a place to put the response. We're just calling it response. It could be anything.
So it's
it could be string, it's a variable. It's just another variable. So it could be string, input from keyboard. We can call it whatever we want to.
Yeah, but you have to do that so it can initialize?
We actually, no. This is just one way to do it. I could have actually put string response equals scanner.next if I wanted to. I could have done it either way. Does that answer your question? Okay. Yes?
After you're breaking out the line, you had like how root, but then there was only one quotation. There would be another line.
No. Okay, so here's what happens. It's a little confusing. So we have the open quote and the closed quote. And then this is actually a symbol that gets printed, right? And then, right here, we have an open quote, which might be kind of hard to see because it's kind of being overlapped by the green box. And then this is the closed quote over here.
Okay.
Does that make it clear to you? It's just kind of obscured, but it's there.
I couldn't tell it was double.
Oh. Yes, sir.
Why are the plus signs within the quotations not outside?
So it looks like they're inside the quotations, but they're actually outside the quotations. Maybe what I should do is I should, in future iterations, I should highlight these. But this quote mark goes with this quote mark. And this quote mark goes with this quote mark. Does that answer your question? Okay. And yes?
Yeah, so why does it print on the second line of the output, like the response, even though you don't have anything that says system out the print?
Right, you mean this part right here?
Yeah.
Well, this is just, if a user is typing stuff, then it's going to show up on the screen. That's just made to simulate that. Does that make sense?
So it wouldn't, like in an actual output, it wouldn't show up?
No. So if you sit down at a computer and you type stuff, then it's going to show up on the screen here. That's what that is. It's the user typing. Okay? All right. So I think we're good for now. So let's talk about radix space numbers, because somebody asked about them earlier. Radix space numbers, in other words, numbers with in our case we use decimal, right? Because we're base 10. We have 10 fingers, so we count to everything in tens. The radix just means the dot, right? And a floating point number has a floating radix. It has a floating point, and we can use these types of numbers to represent fractions and portions, right? Like not whole numbers, numbers with parts of a number, on the other side of the radix, on the other side of the period. So like 6.5 or 7.667 or whatever, right? That's what a floating point number is. There are a couple of main types of floating point numbers in Java. The first one is what we call a double, which means double precision floating point number. A double is a 64-bit number, and it's basically has the highest precision of any radix-based number in Java. So let's say that we were doing a calculation of a cost, and we create a variable for the cost. We also create a variable for whatever our multiplier is going to be, because we want to calculate the cost of some object after tax. because, well, have any of you ever been to a country other than the United States, or lived in a country? Okay, so quite a few, yeah. So you probably experienced the same thing that I did in most countries, which is most people actually include the sales tax in the list price, right? But not in the U.S. No, we gotta make people work to know what the price is of an object. So so we got to do this calculation. We got to do a sales tax calculation. So here we have our floating point number called a float, which is a smaller precision floating point number, and that tells us the tax rate. So I set the tax rate to 10.0f. Now, if you remember before, I talked about how if we put a line of text inside double quotes, we call that a string literal, right? Because it's literally what we typed is what's going to go in the data. This is what we call a float literal, meaning that this actual value, 10.0, is a floating point number that we're going to store directly in a variable. You notice that it has the f. The f is because that's how it distinguishes between a floating point, a float, and a double, which has twice the precision. So that's the distinction. In practice, it doesn't matter a whole lot if you have the f there or not, but if you want to specify it, you can. So we set our tax rate, and then we create this scanner, and we say, what is the cost of the original item? And then we read in that cost. Now this is a new method. Last time we saw next, which was to read in a whole line of text. Next double reads in just a floating point number. Is everybody okay with that? So if we have a different type of data, we have to use a different method to read input from the user. We have to use a different procedure call. Okay, so, and then right here, we're going to say that the multiplier is 1 plus whatever the tax percent rate is divided by 100, because this will give us, like, in this case, it will give us 1.1, because the tax rate is 10%. So if we divide 10 by 100, that's 0.1. We add 1, we get 1.1. Make sense so far? This 1.0 is another type of literal called a double literal, right? So we have float literal, we have double. And you notice it's missing the f. It doesn't have the little f by it. And that just means that it's a double precision floating point number. Yes, sir?
Not to seem behind or anything.
No, it's okay.
But you define floating point as radix-based numbers.
Mm-hmm.
What are radix-based numbers?
Good questions. The question, I'm going to rephrase your question. The question was, what is a radix-based number? A radix means a way that we separate a whole number from a fractional number. So our radix, in like human numbers, a radix is a decimal. Right? So the decimal point is the radix. In computers, it's not that straightforward because in computers, they use binary or hexadecimal, and so it's not technically a decimal. So I can't say decimal point because that might confuse, well, I guess I confuse people either way, right? But the radix basically, in human numbers, the radix that we use is a decimal point. But for computers, it's not the same because it's not based on the number 10. It's based on binary or hex. Does that make sense? Yeah. Okay. Yeah, so when we say radix, you can kind of, in your mind, you can pretend that means decimal.
What did you say the next double is doing?
What next double is doing is it's asking the scanner for a number instead of a string of text.
A number.
So instead of like a string of text like we did last time, this time it's saying, get me a number. Specifically, get me the number type double, which is a floating point number.
Okay, can it say like scanner.int?
Yeah, you can. There's a next int. There's actually a next float. There's a whole bunch of them. It's a good question. So the question was, can we get other data types with this? And absolutely we can. Yes. The scanner has lots of different data types built in. Yes.
So just assume it's a string. So if you don't put next anything, it's assuming it's looking for a string.
Right. So if you just do next, it's looking for a string. Yeah. Yes. The question was, what's the difference between a float literal and a double literal? It's just the precision of the number. So a floating point number has fewer bits, and so it's less precise. Or a float has fewer bits, so it's less precise. A double has more bits, so it's more precise. It's just a matter of the level of precision. Does that answer your question? Yeah. Yes?
So you won't encounter any issues about like determinant double, like float.
I'm sorry, I couldn't hear you.
You're using two types of
Yes.
Countering the issue with that, or don't?
Yeah, so I'm going to rephrase the question. The question was, you're using a float to calculate a double. Is the computer going to be okay with that? And the answer is that when you go from lower precision to higher precision, you're always going to be okay. If you go the other direction, sometimes you're going to run into problems. Yes.
How many bits will be in difference between both of those numbers in this example?
Yeah, the question was, how many bits are the difference? Floats are 32-bit floating point numbers. Doubles are 64-bit floating point numbers. Does that answer your question?
Yeah. I feel like it's possible.
Yes.
So will multiplier be float or double after the expression?
Good question. The question is, will multiply be a double or a float after the expression? And the answer is, because I defined the type of multiplier as double, it will be double. It'll take whatever floating point result there is, and it'll convert it into a double. Okay. We're going to talk all about data conversions, but that's the short answer. Yes, and then I'll get you next.
So does that mean that the assignment on the right-hand side, that's going to be a float, which is then converted?
Right, exactly. So the question was, does that mean it's going to be a float which is converted? Yes. The short answer is yes. This tax percent divided by 100 float, those are both floats, so that result will be a float. Then when it gets added to that 1.0, which is a double, it will get converted to a double before it gets added. Okay, and then it's you, right? Yeah.
Because multiplier is a double, is that why you put the 1.0 instead of 1?
Oh, the question was, because is the reason that I put 1.0 instead of 1, because multiplier is a double. And the short answer is yes. That way it doesn't have to convert an integer into a double before assigning it. It just makes the operation a little faster. So like when you're working with floating point numbers, if you add the decimal point, it'll automatically make that number a double, which will make it more efficient to do the computation. But I could have put 1 and it would have worked.
But it takes longer to compile.
Yeah, well, it takes longer to execute. And actually, you know what? I should test that, because actually, if you didn't have the decimal point, it might actually get truncated. It might drop to 0.1. So we can test that with the compiler, though. Well, keep that in mind. Let's test it at the end, okay? And a lot of times when we're not sure what's going to happen, I advise this. I highly recommend just try it. If you don't know what's going to happen, try it and see what happens, because that's a great way to find out what will happen, is to actually do it. So, yes.
Why did you specify that the 10 was a floating number when you could have just made it a double?
The question was, why did I specify that the 10 was a floating point when I could have just made it a double? And the answer is because I wanted to demonstrate floating point numbers to you. not because it makes sense. Yes? Yeah, the question was, if you have multiple floating points, what?
How do you specify what floating point to pull?
Like, which floating point type to pull, you mean, or? Well, that's a good question. So it all depends on what types you're starting with. If you're doing an operation with two different 32-bit floats, like the float type, then the result is going to be a float. If you start with a 64-bit and a 32, a double and a float, it's going to end up being whichever one is on the left side. So there's a bunch of rules about exactly how the type conversions happen, but they're very precise. They're very specific. There's a specific ordering it goes through. Okay? And we are going to go into all of those details pretty soon. Okay, so we have 5:10. Is that? Yeah, no, it's earlier than that. 4:55. So we got 10 minutes. Yeah. So in this case, if I said the original cost of the item was 1010, the multiplier is going to be 1.1, so the final cost is going to be 1111. Okay? Good so far? All right. So floating point numbers. Why don't we just use them for everything? Which is paraphrasing what somebody said earlier. And the answer is because it can cause you all kinds of problems. So does anybody know, if I have an integer and I do 5 divided by 0, does anybody know what will happen? You're going to get it, well, close. So somebody said undefined, which is the correct mathematical answer, but does anybody know what happens in a computer?
I think the compiler error or something, compiled time
So
error.
if the compiler can catch it, it will give you an error. But what if the compiler doesn't know the value? You know what happens? What's that?
Infinity?
Oh, that's also a good answer. Somebody said infinity. Hold that thought, because we're going to come back to that. That's not quite right for integers, but we're going to see that it does happen. Yes?
It's going to keep putting 0 into 5 forever and not actually do anything at that point.
So If there weren't a special part of the CPU to catch that problem, that would be true. Yes. So somebody said it would just keep trying to divide 0 over and over again. And if the CPUs were not built specifically to catch this kind of error, that's exactly what would happen. But actually, the CPU will detect when you try to divide an integer, or any integer, by 0. And it will throw a special type of error called a divide by 0 error. And it'll basically, your program will crash. And that's exactly what happened. It will just crash. And the error message will literally be divide by 0. Like, that's the error message. Like, you tried to divide by 0, you're not allowed to do that. Shame on you. But with floating point numbers, that's not true. With floating point numbers, this goes back to something somebody said earlier, if you divide 5 by 0, it results in infinity, which is actually a floating point representation number. They actually have a floating point representation for infinity. So what does that mean? That means you messed up toward positive infinity, because you're never supposed to do that. Never, ever, ever are you supposed to divide by 0. What if you have negative 5.0 divided by 0.0? It's going to be negative infinity, which means you messed up towards negative infinity, right? And what do you think happens if you try to take the square root of negative 1.0? And keep in mind, this is in the computer world, not in the mathematical world. No ideas? It gets a result called NaN. Anybody have any idea what that stands for?
No, not a number.
Not a number. So don't do that. So this seems like, well, why would you ever do that? Nobody does it on purpose, right? These kind of errors, they don't show up because people do them on purpose, usually. Every once in a while, people will use positive and negative infinity on purpose because they do have some special mathematical values. Nobody intentionally creates not a number because not a number means shit is broke. That's what it means. Okay? I don't know any other way to put it. Like this is like a disease that will spread through your data. Because what do you think happens if you take something that's not a number and you multiply it by another number? What do you think the result is?
Not a number.
It's not a number. What if you divide by something that has not a number in it? Not a number. Multiply, add, subtract, divide, modulo. Do anything with not a number, and the result is also not a number. So basically, it spreads through all your data. And I've seen people like hang their heads in despair because all of their data were corrupted by this not a number symbol. So I'm kind of making light of it, but it's actually really important to recognize that you got to be careful with floating point numbers. That's why most of the time, if we can use integers, we use integers because floating point numbers have a lot of errors. They also are, even though we think of them as having higher precision, for exact integer values, they are actually less precise because they're an estimation. So a lot of times you will have an infinite decimal number, right? So like 1 divided by 3 is 0.33333, and so on and so forth, right? But if you remember that in a computer, that's eventually going to get cut off somewhere. So if you add these numbers together and you're doing a lot of operations, they can end up being off by just a little bit. That's just enough to mess everything up, right? So the moral of the story is, use floating point numbers when you need them, and if you don't use them, right? Okay, any questions up to this point? Yes?
What happens when you divide by what?
What happens when you divide by what?
Sorry, you take the square root of the negative then.
Of a negative integer. Oh, well, it'll convert it into a double, and then it'll turn it into not a number. Yeah. Yes, sir. The question was, why would you ever use a floating point number over a double? And the answer is, today you probably wouldn't, honestly. Like in modern computers, you probably wouldn't. Remember the difference is 32 bits versus 64 bits. For a very long time, most processors were not bigger than 32 bits. So a 64-bit number had a very big overhead cost. Today, that overhead cost doesn't really exist. So, well, actually, no, that's not true. A lot of phones are still 32-bit, actually. So if you're writing software for a phone, then there's a big performance difference there. Does that answer your question? Okay, so